Okay, let's take a look at piecewise defined functions. Now we've seen these graphs before. These are the graphs that are constant, then they go up, and then they look like a parabola, then they look like a line, or they're broken somewhere. Those are piecewise defined functions. A practical situation where you might run into this is in shipping. The more you ship, the lower price per ounce or price per hundredweight if you're talking about large shipping. Utility companies might also give breaks on how much you're using every month. In our examples, we're just going to use the basic algebra functions so we can make them pretty easy for us. So we're going to have this first one. It's got 3 different rules depending on what x value we're using. So I'm going to use the formula x squared if I'm using an x that's less than or equal to 0. I'm going to use just 4, my answer is going to be 4, don't have to do anything, if my x value is between 0 and 2 inclusive of 2. And finally, I'm going to use the formula x minus 1 for any x's that are greater than 2. So the first one I have here is f of negative 3. Where does that fit in these breakdowns? Well, negative 3 is less than 0, so we use the first rule, square, and get 9. Right? The next one, f of 2. In this case, I have to be kind of careful because it's in 2 formulas, so I have to pay attention. Where is it actually included? The 2 is actually included with the second rule, so my answer here is simply going to be 4. And then finally here I have f of 5. Well, 5 is not between 0 and 2, it's greater than 2, so we're going to use the final formula here and do 5 minus 1 to get an answer of 4 there as well. All right, here's another one. It's pretty simple. You just got to figure out which rule to use. So let me give you a second. Take a look at this. F of negative 4. Where does that fit in our listing? Well, I always start at the top. Is it in this one? Yeah, negative 4 is less than negative 2. So I'd put it into this first formula of negative 5 times negative 4, subtract 8, and I believe that's going to be a 12. Now look carefully. What about f of negative 2? Where does that fit? Do we use the top rule or the second rule? Where is it included? Not included on the top, but it does have negative 2 less than or equal to x here. So for this one, we have to use the second rule. In that case, we do a half times negative 2 plus 5, get an answer of 4. What about for the 4? Well, 4 is also included in the second rule. So we're going to still stick with the second rule for that one, and you should come up with 7. Finally, I've got f of 6. Okay, well, f of 6 is not going to be in between here. It is greater than 4, so we're finally down to the last rule here, 10 minus 2 times 6, and I got negative 2. All right, we also want to be able to graph these. It's really not as hard as you think, but I do not recommend doing it in the calculator. It's very tedious to do. We're going to be using simple equations, so they're going to be easy to do by hand. Okay, so I've got 2 basic rules here. The first one for less than or equal to 0, and the second one for greater than or equal to 0. So we're going to do them one at a time. So I'm going to take my first thing and make a note. This is for the x's that are less than or equal to 0. That's important because that tells me what numbers to put in my table. I only want things that are less than 0 or equal to 0. Actually, I always put that breakpoint, and then you notice I put a little solid dot here because I know it's going to be included because it's got the or equals to. Okay, on this other rule, we'll come back there in a second, but on this other rule it says x is greater than 0. It doesn't have the or equals, so I still put 0 as my starting point in my table, but I put a little open circle there to remind myself that's just going to be a placeholder. Okay, so I need x's that are less than or equal to 0. I'm using the formula negative 1/3 x plus 2. So I want things that are going to come out nicely. I'm going to use multiples of 3. So negative 3, negative 6. Plug those in, do the arithmetic, and I get some ordered pairs. 0, negative 2, negative 3, 3, negative 6, 4. I do not get a full line because it stops at 0. Now I'm going to take the second one, and I'm going to make a table there, again starting with 0, but this time note that I want x is greater than 0. There's no fractions involved, so I'm going to go straight 1, 2 as my next points, plug all those in, get some more ordered pairs. So at 0, negative 5, I use a big open circle because this is a function, right? It has to pass the vertical line test. If I were to draw that vertical line there, it would pass. And then the next one would be 1, negative 4, 2, negative 3, and so on. And that's your graph.